Hello friends, welcome back to my YouTube channel. Uh, in this video, I'm continuing my discussion on distillation. This will be part 15 of my discussion on distillation, and in this I'll be talking about rectification. This is one type of distillation. Okay, so rectification. In this introductory video, I'll be introducing rectification, continuous rectification to you. Okay, now let us understand continuous rectification. Basically, continuous rectification is a counter-current distillation operation, continuous counter-current distillation operation, in which vapor and liquid phases they flow counter-current to each other, and as they flow counter-current to each other, they are contacted with each other. Okay, so the vapor and liquid phases they are contacted in a counter-current manner. It was invented by Annius Coffey in 1830. He used distillation, he used continuous rectification for distilling ethanol from fermented grain mash. So for the first time, Annius Coffey in the year 1830 used continuous rectification for getting ethanol from fermented grain mash. As compared to simple and flash distillations, continuous rectification is relatively new. I have already discussed about simple and flash distillations in my earlier videos, so please watch them. Continuous rectification, it is mostly carried out in vertical cylindrical vessels, and these vertical cylindrical vessels we call them as distillation columns. These distillation columns, they may be tray columns or pack columns, but mostly for carrying out continuous rectification, tray columns are popular as compared to pack columns. Tray columns are more popular for continuous rectification. Okay, now let us understand how rectification is carried out in tray columns. So let this be the cylindrical vessel, and this dash line they are representing trays. Okay, so a cylindrical vessel in which you have trays. So now this is a tray column. Feed enters on one of the tray, which is almost located centrally. We call that as feed plate. I'll talk more about it. Then it flows down from one tray to the other to the bottom, and from bottom it is taken out, sent to a reboiler where it is heated to create the vapor phase. The resulting vapor phase is admitted into the column, and that vapor phase rises through the column, and finally it is taken out at the top, and then it is sent to a condenser where it is condensed, and the resulting condensate is divided into two parts. One is sent back to the column as liquid phase on the top tray, then it flows down, and whereas the other fraction is taken out as a product, which is top product. Similarly, one product is taken out from the reboiler, it is the bottom product. So in this way the column is operating. Okay, so now I just told you how the column is operating. Feed enters into the column on a tray, then it flows down to the reboiler. It is heated in the reboiler, boiled in the reboiler to create a vapor phase. The vapor phase rises through the column. It is taken out from the top, sent to the condenser. The resulting condensate is divided into two parts. One is sent back to the column, the other is taken out as a product, and the other product is taken out from the reboiler. Now let me talk about the feed solution. We are going to consider a binary mixture of components A and B. So for our discussion, in order to make it simple, I am considering a binary mixture, that is mixture of two components, mixture of only two components. Which are these two components? A and B. Out of this, A is more volatile component, that is A has low boiling point and high vapor pressure as compared to that of B. Then how feed is introduced into the column? It enters on an almost centrally located tray. We call that tray as the feed plate or the feed tray. The plate or the tray on which feed is admitted into the column, we call that as feed plate or feed tray. Then after entering on the feed plate, the feed flows down to the reboiler. So feed is entering on a tray, we call that tray as feed plate, and then it flows down to the reboiler. So what is done in the reboiler? Inside the reboiler, the solution is boiled. It is heated so that it boils and a vapor phase is created out of it. So vapor phase is created out of it, and then it enters the resulting vapor phase is admitted into the column at the bottom, and then it will be rising up, taken out from the top. The other thing you already know. Okay, so in this way uh, the column is operating. Okay, so vapor phase is now entering. What happens to it? Now let us understand. The vapor phase, it rises through the column, as I said, then it is removed from the top, and then it is condensed in the condenser. So vapor phase, it is removed from the top, it is sent to the condenser, and it is condensed in the condenser. The resulting condensate, it is divided into two parts. So one is removed as the distillate or the top product, whereas the other part is sent back to the column, and that is called as reflux. We call that as reflux. So distillate is taken out as one part of the condensate, and reflux is sent back to the column. Okay, so now let us see what happens on individual trays. So we understood how the feed solution flows down to through the column to the reboiler. Vapors enter into the column at the bottom. They are taken out at the top, sent to the condenser. The resulting condensate is divided into two fractions. One is the top product and the other one is reflux. Okay, now let us understand what happens on individual trays. So we are now going to understand what happens on these trays. So on each of the tray, the two phases, which two phases? Vapor and liquid, these phases are contacted. So on individual trays, vapor and liquid phases, they come in contact with each other, and during this contact, mass transfer occurs between them. That is, components are transferred between the two phases. And what is the result of this mass transfer? Due to this mass transfer, the mass transfer occurs so that the two phases come to equilibrium. So they tend to come to equilibrium, they try to reach equilibrium, and once this happens, in reality they will not reach, you can say, the exact equilibrium, but they will go close to equilibrium. And once this happens, they are physically separated from each other. So all this happens on individual trays. So in one way, we are saying that we can say that each tray is acting as a stage. So you know what is a stage? Stage, in stage-wise contact, a stage is a device or combination of devices where the two insoluble phases come in contact with each other, mass transfer occurs between them so as to bring them to equilibrium, and then they are physically separated from each other. ठीक है. If they reach exact equilibrium, you have ideal stage, theoretical stage, but in reality they will come close to equilibrium. Such a stage will be a real stage. So in real stage the two phases are close to equilibrium. ठीक है. So the point was each tray in the tray column is acting as a stage, and this all is happening on those trays. ठीक है. Now let us know more about distillate, which is the top product taken out from the condenser. So distillate, or the top product, it will be continuously removed from the condenser. And what is its peculiarity? It is rich in more volatile component. So in our discussion we had considered two components, A and B. A was the more volatile component. So in this case distillate will be rich in A, rich in the more volatile component. This will always be true. The bottom product, which is taken out from the reboiler, you can also call it as a residue. The bottom product or the residue, it is continuously removed from the reboiler, and it will be rich in the less volatile component. In this case it is B. Okay, so in this way you are able to get A rich solution at the top and B rich solution at the bottom, and you can increase its purity. So you have achieved a separation where the two components are separated purely on the basis of difference in their boiling point. Okay, so residue or the bottom product, it is taken out continuously from the reboiler. Okay, now let us understand more about the tray column. So for that I am drawing a schematic of a typical tray column. So let this represent the column. These are the trays inside the column. Then I am numbering those trays. This will be the first tray, first plate, and this will be the last plate in the column. Let it be nth plate, capital nth plate. Then feed is entering on one of the tray, which is almost located centrally. I'll talk about the notations shortly. So this will be the feed plate. Then I'm considering any plate, that is nth plate. Now this nth plate is in a section that is above the feed plate. Then I'll consider one more plate. I'm calling it as mth plate. Mth plate is in the section that is below the feed plate. Okay. So I'm saying that feed plate divides the column into two sections. So one is that section that is above it, and the other one is the section that is below it. Okay. So the feed will be flowing down. It will be taken to the reboiler. It will be heated in the reboiler, where let us say that QR, heat is added at a rate of QR. To create a vapor phase. The vapor phase is admitted into the column at the bottom. It rises up. It is taken out at the top. Then it is sent to the condenser, where heat is removed from the vapors at a rate of QC. Then condensate is divided into two fractions. One flows back to the column, whereas the other is taken out the product, taken out as product. It is distillate or top product. And then I'll talk about the notation shortly. The other is taken out, sent back to the column as reflux. Then I'll talk about the notations. Then reflux will flow down to the column, to the reboiler. Then bottom product is continuously removed from the reboiler. We call that as residue or bottom product, and these are the notations that we will be using in the notation. I'll talk about the notations shortly. ठीक. Now let us understand. So I have taken the schematic. The feed solution, again as I said, it is a binary liquid solution of components A and B. A is the more volatile component. F, now let me talk about the notation. F is the molar flow rate of feed. So it could be kilo, for example, it could be kilomole per second or kilomole per hour, mole per second, molar flow rate. And XF, it represents mole fraction of A in the feed solution. That is mole fraction of more volatile component in the feed solution. Okay. Then let us talk about the distillate or the top product. So distillate, D represents its molar flow rate, kilomole, for example, kilomole per hour, kilomole per second, and XD, it represents mole fraction of A, that is more volatile component. Similarly, for the residue or the bottom product, W represents the molar flow rate and XW represents mole fraction of A, mole fraction of more volatile component in it. Then for regarding notations for reflux, you have L0, the molar flow rate of the reflux, and XD represents mole fraction of A. You need to understand in the condenser you are dividing the condensate in two parts. The point is they will have the same composition. That's why in the reflux also mole fraction of A is XD, same as it is in distillate. Then the reboiler. In the reboiler, as I said, we are adding some heat and let the rate be represented by QR. And in condenser, you are removing heat from the vapor and let it be done at a rate of QC. So QC represents rate of heat removal, QR represents a rate of heat addition. Okay, now let us move ahead. Now let us talk about the section that is above the feed plate. What happens in this section? Let us understand. So in the section above the feed plate, what happens? The liquid phase, which is due to the reflux. So in the section that is above the feed plate, liquid phase is due to the addition of reflux. So the liquid phase due to reflux, it comes in contact with the rising vapor. So this is the liquid phase, and it comes in contact with the vapor phase. During this contact, what happens? The less volatile component, in this case component B, the less volatile component from the vapor phase is continuously absorbed into the liquid phase. So less volatile component, which is in this case B. So B from the vapor phase, it is continuously absorbed into the liquid phase. This happens in the section above the feed plate. Okay. And due to this, what happens? The vapor phase is continuously enriched with more volatile components. So as less volatile components continuously gets absorbed into the liquid phase, what happens? What is the end result? The end result is vapor phase gets enriched with component A, the more volatile component. So when the less volatile component is getting removed, as it gets absorbed into the liquid phase, the vapor phase itself will be becoming rich in more volatile component. So that's why I'm saying the vapor phase is continuously enriched with the more volatile component. And due to this, we call the section above the feed plate as enriching section. Why enriching section? Because the vapor phase in this section is getting enriched with more volatile component, or the other name given to this section is rectifying section. So it is either the enriching section or the rectifying section. Okay. Now let us understand what happens in the section below the feed plate. So it will be having a different name. Let us understand that. So in the section below the feed plate, what happens? The vapor phase that is rising from the reboiler. So we are talking about this vapor phase that is rising from the reboiler. it comes in contact with the liquid phase that is flowing down. So liquid phase that is flowing down. Now below the feed plate, liquid phase will have addition of the feed and the reflux. So it will be a result of addition of two liquid phases. One is the feed and the other one is reflux. So the vapor phase that is rising from the reboiler, it comes in contact with the liquid phase that is flowing down. So vapor phase is rising, liquid phase is flowing down, and now there is contact between these two. So during the contact, what happens? The liquid phase is continuously stripped of the more volatile component by the vapor phase. So in this section below the feed plate, the more volatile component is continuously stripped out of the liquid phase. So in this case, A gets transferred to the vapor phase. So in the top section, B was getting transferred from liquid phase, vapor phase to the liquid phase, and in the section below the feed plate, A is getting, more volatile component is getting transferred to the vapor phase. Okay, so during the contact, liquid phase is continuously stripped off the more volatile component by the vapor phase. And what happens due to this? You are removing A from the liquid phase. So in one way, the liquid phase is getting exhausted of the more volatile component. So in the section below the feed plate, the liquid phase gets exhausted of the more volatile component, and that's why this section is either called exhausting section or stripping section. Why exhausting section? Because the liquid phase gets exhausted of more volatile component. Why stripping section? Because more volatile component is continuously stripped off the liquid phase. Okay, so now we know the feed plate is dividing the column into two sections. One that is above the feed plate, we call that as rectifying section, or the other name given to it is enriching section. And the section below the feed plate, we call that as exhausting section, or the other name given to it is stripping section. Now henceforth, whenever in our discussion on tray column, you should remember this, the rectifying section and then the stripping section. Okay, now let us move ahead. Now let us know more about what happens inside the column. So inside the column, the liquid phase is always at its bubble point. You need to remember this. The liquid phase is at its bubble point and vapor phase is at its dew point. So liquid phase will always be at its bubble point and the vapor phase will always be at its dew point. That is, liquid phase will be on the verge of boiling and vapor phase will be on the verge of condensing. Okay. So temperature, if you have to talk about temperature inside the column, then temperature is highest at the bottom and it is lowest at the top. So as you move from bottom to top, what happens to temperature? Temperature decreases. Okay, so temperature, it is increasing from top to bottom. So one thing is, if you move from bottom to top, temperature is decreasing, and if you move from top to bottom, temperature is increasing. You always remember this. If somebody asks you about temperature profile in the column, then you can talk about it. Okay, and it decreases from bottom to top. So as you move from bottom to top, temperature will be decreasing, and as you move from top to bottom, temperature will be increasing. You have to remember this. Okay, so with this In my short discussion on introduction to atypical rectification, I have introduced rectification to you, continuous rectification to you. Then I have talked about how it is carried out in a tray column. What are the two sections in the tray column? So with this, I end my discussion for introduction to rectification. I'll continue discussing more about rectification in my coming lectures, video lectures. Please subscribe to my YouTube channel. Thanks for watching this video. You please subscribe to my channel. If you really like my videos, you please hit the like button, hit the bell icon so that you'll be notified as soon as I upload any new video. Thanks for watching. Do subscribe to my channel. Tell your friends to subscribe to my channel. For now, have a nice day and be with me.